try a growth and decay situation. So here is the formula for growth and decay. So if you hear those words in a problem, that should be your red flag that you should be using this formula right here. The letters don't really match up to what I think they should, but just remember, x is really, it's the exponent, but it really just is the time. I don't know why they can't just use the t for time. A is the original amount. Again, I don't know why they can't just use the P for principal. It would make more sense to me because this is mimicking, a compound interest formula. But anywho, and then B is your growth factor. So if it's going to grow or if something's going to appreciate in value, you are going to add your rate as a decimal to 1. If it's going to decay or decline or go down or decrease, those are the trigger words, you are going to subtract your rate as a decimal from 1. So let's look at this situation. Karen purchased a home for $250,000. A real estate agent appraiser informs her that the property values have appreciated. So if they appreciate, we're going to go ahead and use this growth factor situation. So that means we need to calculate our B first. So our B is going to be 1 plus our rate. Our rate is 2.5%, which is 0.025. So our B is 1.025. So here's what your equation would look like. Y equals 250,000, because that's your A, which is really a fancy word for, starting amount. I think of it as principal, but. And then we're going to multiply that times our B, which we just calculated as 1.025. And then we're going to take that to our exponential power, which is our time. And in this case, it's 5 years. So again, just remember to do things in the correct order of operation. So you're going to go ahead and take 1.025 and raise that to the power of 5. And I'm getting 1.13, blah, 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 some crazy decimal that goes on. And I'm going to multiply that times my starting amount, which is $250,000. And I am getting a new amount after 5 years of $282,852. So since it went up, obviously we should get a higher number than what we started with. Now let's look at this same situation, but let's pretend instead, the housing market is going down and it's declining. Let's figure out what we would do in that case. We are going to go with a decay situation. So then we would be using this formula for our growth rate. Our growth factor would be 1 minus the rate of 0.025. Okay, so 1 minus 0.025 would be 0.975. So this is our B. So that's going to go right here in place of B. We're still using the same time, and we're still using the starting amount. Okay, so here we go. Y equals $250,000. This could be a house. Maybe this is our Ferrari. Let's pretend our Ferrari is declining in value. Our B we just calculated is 0.975. And again, our time, we're going to go ahead and use the same time. Our X, we're going to just go ahead and say is 5 years. Okay. So here we go. I'm going to raise the exponent first. Order of operations says exponents come first. Take my 0.975, raise that to the power of 5, and I get some crazy decimal, 0.88109, blah, blah, blah. And you don't want to round until the very end because it will cause your answer to be slightly off. I'm going to multiply that times the 250,000, and my new amount is 220. So if our house declined in value or went down, or our poor Ferrari lost some value, it would be now worth $220,273. So you can see how a growth affects the B, and then a decay, you subtract from 1 to get that B. Okay, and again, just check for common sense. Make sure if it's declining, your number should be smaller. If it's growing, your number should be bigger. Okay, this is our last type of situations for this unit. Here, your trigger word is going to be the word continuous. When you hear the word continuous in one of these problems, you're going to go ahead and you're going to use this formula right here. It looks weird and ugly, but again, we're going to let the calculator do the work. So P is the, original amount, principal, that one's fine. E, you guys, E is not a variable. It's literally a button on your calculator. E is kind of like, I don't know, maybe pi. It literally has its own value. So just use that button on the calculator. And then R, again, is rate, written as a decimal, and T is time. So here we go. Amount equals, so let's look at this situation. A city has a population of this, so this is our starting amount, which is our principal, and grows continuously. So we know we're using the right formula, and this is our rate. So if this is our rate, we're going to go ahead and write it as 0.035. And then they want us to predict how many people in 10 years. So this is our time. So here we go. Amount equals 5,365 times E. We're going to leave E as is. And then this exponent is going to be 0.035 times 10. Okay, so first I would do that on my calculator. And when you do this times 10, you can see my exponent turns into 0.35. Okay, so the first thing is to find that E button on your calculator and take E, and it's probably going to say maybe 2.7 something, and you're going to hit the raise to the power of button, and I'm going to raise it to the power of 0.35. And so I'm getting that this chunk right here, when I raise E to that power, I get like 1.41 blah, 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 blah. And then the last step for order of operations would be to multiply by the original amount, which is 5,365. And I'm showing this population would be 7,613 people in 10 years if it continuously grew at a rate of 3.5%. Now, what if the population was declining and it was going down? If that were the case, you take your rate, this is going to be weird, and you give it a negative sign. So if it was going down, this is what you would do instead. You would have your original population of 5,365, but your E would literally be negative 0.035 times 10. Okay, and now, again, you're just going to punch that into the calculator. I know it's wonky, but when you do 0.35 negative times 10, and then you raise that to the power of E. So raise that to the power of 0.35 negative equals, I'm getting that just this E raised to the power is 0.704 blah, 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 blah. And then again, the last step is to multiply by your principal. So I'm going to multiply that times 5,365, and I am getting a new amount of 3,780 would be the population if it went down instead of going up. And that sounds about right. That makes sense. Okay? So again, if it's growing, you just do the rate normal. If it's declining, decreasing, going down continuously, you get to use a negative R as your rate. It's going to sound weird because you're like, I don't think I can have a negative exponent, but because of the E, it works out.